In losing the moon, Earth does not lose life, but it gains a new rhythm, one of challenge, adaptation, and relentless survival.
What would it mean if the night sky had never known the moon? For billions of years, the pale glow of that distant sphere has risen and fallen in silent rhythm, shaping tides, inspiring art, and anchoring the passage of time itself. It has been our companion since before we were human, watching over shifting continents, evolving species, and the quiet awakening of life on Earth. But what if that light had never existed? What if the sky had always been dark? No silver reflection, no orbiting sentinel to mark the night's turning. The story of Earth would not simply be missing a celestial decoration. It would be rewritten from its very foundations. When we gaze at the moon, we see something constant, a calm face in a universe of chaos. It doesn't shine by its own power, but by the light of the sun, a mirror suspended in the void. That faint shimmer has comforted civilizations, guided travelers, and given poets something eternal to describe. Yet behind that soft glow lies something far greater, a gravitational partnership that has defined every motion of our planet since the dawn of time. Without the moon, the very idea of stability on Earth becomes uncertain. Long before humans existed, before oceans settled and skies turned blue, the early Earth was struck by a planet-sized body. Theia, as scientists call it, that cosmic collision threw molten rock into orbit, which eventually gathered to form our moon. It has circled us ever since, slowing Earth's rotation, pulling on our oceans, and keeping our axis tilted at just the right angle for life to thrive. Now imagine that collision never happened. No Theia, no moon, just Earth, alone. In that alternate beginning, Earth would still form and spin, but it would spin faster, a full rotation lasting only a few hours. Winds would howl across its surface at unimaginable speeds. The young planet's axis would tilt and sway wildly, sending seasons into unpredictable chaos. Instead of the gentle rhythm of day and night we know, there would be violent shifts between scorching heat and bitter cold. The poles might drift. The equator could freeze. The pattern of climate, the very heartbeat of the planet, would have no anchor to hold it steady. Even the oceans would be strangers to us. Today, the moon's pull creates the tides, vast movements of water that rise and fall in perfect cycles. But in a moonless Earth, tides would still exist, only weaker, drawn by the distant tug of the sun. They would be smaller, quieter, almost imperceptible. That might seem like a small change, but tides are more than waves. They are engines of motion, stirring the seas, mixing nutrients, shaping coastlines. They are nature's clock. Without them, the oceans would fall still, and so would much of the life within them. And yet, beyond the physical effects, there's something deeper, something human. Without the moon, our nights would be truly dark. The stars would burn brighter, yes, but the world would lose its gentle half-light. The landscapes that glow under a full moon would be drowned in shadow. Early humans, if they ever emerged, might have feared the night even more. There would be no glowing guide above the horizon, no reliable measure of passing months. The rhythms of early civilization, harvests, rituals, calendars, might never have found their balance. The moon gave humanity something intangible, the ability to measure time and imagine beyond survival. Its cycles offered predictability in an unpredictable world. Every culture that ever looked upward found meaning in that pale light. Gods, myths, love, destiny. Its absence would not just change the sky, it would change the soul of civilization itself. The moon's existence shaped more than tides and calendars. It gave Earth its emotional gravity. Without it, our species might have evolved under different stars, speaking different stories, never realizing what was missing. As we begin to imagine this world without a moon, we are not simply removing a celestial object. We are erasing a cosmic balance, a silent companion that has guarded the Earth from chaos for billions of years. And in that silence, the question remains, if the moon had never been born, would we? The story of the moon begins with catastrophe. Over 4 billion years ago, the young Earth was struck by a wandering world, a planetary body the size of Mars, known today as Theia. The collision was so violent that it melted the Earth's crust and flung molten debris into space. That debris gathered, cooled, and coalesced into the glowing sphere we now call the Moon. It has circled us ever since, slowing the Earth's spin, stabilizing its tilt, and quietly dictating the rhythms of our world. Every wave that touches a shore, every season that marks time, every gentle nightlight hanging in the sky, all born from that one impossible accident. But what if it never occurred? What if Theia missed? What if that collision, the one that made us what we are, simply didn't happen? In this alternate beginning, Earth forms alone. There are no fragments of molten rock orbiting above, no companion reflecting sunlight back upon its surface. The newborn world spins fast and furious, completing a full rotation in perhaps 5 or 6 hours. A day passes in what feels like an instant. The planet's rotation tears at its own atmosphere, driving winds across its molten oceans at unimaginable speeds. Lightning cracks continuously. The crust trembles, unable to settle under such rapid motion. There is no moon to slow the spin, no gravitational tug to act as a brake. The planet whirls endlessly, trapped in its own momentum. With that relentless rotation comes instability. On the Earth we know, the Moon serves as an anchor, a quiet force holding our planet at a stable 23.5-degree tilt. That small angle is the reason we have seasons, the reason life can adapt to predictable cycles of warmth and cold. But remove the Moon and the balance disappears. Without its steady pull, Earth's axis becomes a wandering thing, a wobbling top without a guiding hand. Over thousands or millions of years, that tilt could shift wildly, from almost upright to almost horizontal. At one point in history, the North Pole might bask in eternal sunlight, while the South Pole freezes in perpetual night. Then, in another age, the balance could reverse. Entire ecosystems would collapse and reform as climates reshaped themselves again and again. The Earth would be alive, yes, but in constant flux. Astronomers have modeled such a world. Without the Moon, the Earth's axial tilt could vary by as much as 60 degrees over geological timescales. That means ice caps melting into oceans, tropical jungles freezing solid, and deserts blooming into meadows, only to vanish again centuries later. The result isn't just chaos in temperature or weather, it's chaos in time itself. There would be no rhythm to anchor the planet's story, no steady path for life to follow. Imagine trying to build civilization in a world where the sky itself could change from one lifetime to the next, where constellations drift, seasons blur, and generations grow under entirely different suns. Even the length of a day would become alien. In our reality, the Moon's gravity acts like a cosmic brake, slowly dragging at Earth's rotation. Over billions of years, it has stretched our days from a mere 18 hours to the 24 we know now. Without that pull, the Earth would continue spinning at breakneck speed, 10-hour days. A sun that rises and sets faster than life can adapt. Shadows would crawl across the ground with dizzying speed, and the winds, driven by that rapid rotation, would howl across continents that never truly rest. A faster spin also means stronger storms, greater tectonic strain, and a planet perpetually on edge. It's not just the sky that changes, but the heartbeat of the entire world. The Moon's absence turns the Earth into a place of extremes, a world of chaos and motion where even gravity feels impatient. The seas churn without rhythm, the air screams across the surface, and the tilt of the planet drifts like a pendulum without purpose. In such a world, stability is a luxury that never existed. Each sunrise could mark a new climate, each century a new world. This Earth would never stand still, not for a moment. It would spin faster, tilt deeper, and breathe harder than ours ever did. And yet, within that endless motion lies a haunting question. If the Moon never came to slow the storm, could life have found a way to survive it? If the Moon had never formed, the Earth's surface would look strangely familiar at first glance. Blue oceans, drifting clouds, a glowing sun above. But beneath that beauty lies a silent truth: the seas would be almost still. The tides that shape our coastlines drive marine life and breathe energy into the planet's circulation are born from the moon's steady gravitational pull. The sun contributes a smaller influence, but it is gentle, a whisper compared to the moon's constant tug. Without that companion, the rise and fall of the oceans would shrink to a fraction of their current strength. The great tidal surges that define the rhythm of our shores would fade into shallow ripples. The coasts would sleep. The ocean's restlessness isn't just motion, it's life itself. In our real world, the movement of tides mixes the seas, circulating nutrients from the deep to the surface. It's this invisible cycle that feeds plankton, supports coral, and sustains the base of the food chain. Remove it, and the ocean begins to stagnate. In a moonless Earth, much of the sea could become layered and lifeless, a surface of calm above a heavy, oxygen-starved deep. The water might glow with heat in some places and freeze solid in others, each region locked in its own rhythm. The birthplaces of life, those shallow tidal pools where chemistry met sunlight, might never form at all. Some scientists believe that the moon's tides played a crucial role in the transition from simple molecules to living cells. When the first organic compounds gathered along ancient shorelines, the regular flooding and retreat of tidal waters provided a natural engine, concentrating and drying materials again and again until the spark of complexity ignited. Without that push and pull, that repeating dance of exposure and renewal, life's earliest experiments could have remained trapped beneath the waves. The chemistry might still happen, but slower, perhaps too slow for complexity to ever take hold. A moonless Earth might have oceans teeming with potential, yet forever silent. A planet full of ingredients, but no recipe. Even if life did begin in such a world, its path would be very different. The first organisms might rise in the deep ocean, near hydrothermal vents, shielded from the planet's unstable surface. These early creatures would live in darkness, feeding on minerals and heat rather than sunlight. But evolution, robbed of tides and stable climates, would struggle to reach beyond those depths. The surface would be hostile, battered by violent storms, then frozen under shifting poles. The land, if it ever became habitable, would be reshaped again and again by the planet's wandering tilt. Civilization, in any recognizable sense, might never arise. The moon also affects more than water. It influences air. Tidal forces subtly shape the movement of the atmosphere, stabilizing wind patterns and moderating global temperatures. Without it, weather systems could become far more erratic. Imagine hurricanes the size of continents, lightning storms lasting weeks, and polar winds that change direction with every tilt of the axis. The boundary between calm and chaos would blur, creating a planet that breathes in storms and exhales silence. It's easy to imagine such a world as lifeless, but perhaps it would simply evolve differently. If evolution has one constant, it's adaptation. Maybe life would learn to thrive in the instability. Perhaps creatures would evolve rapid growth cycles, capable of reproducing before their environment shifts again. Some might migrate vast distances, following fleeting pockets of warmth or calm seas. Others might burrow deep underground or beneath thick layers of ice, surviving the extremes until the planet swings back into balance. Life could emerge, yes, but it would be restless, nomadic, and unanchored. Each generation would face a new world. In such a world, even the concept of night would be transformed. With no moon to reflect sunlight, the nights would be darker than any we've ever known. The stars would blaze with terrifying clarity, unsoftened by lunar glow, for early creatures, and one day, perhaps, thinking beings, darkness would carry a different weight. It wouldn't just be the absence of light. It would be the presence of emptiness. The moon's light gave humanity comfort, a sense of permanence in a shifting sky. Without it, the world would feel deeper, lonelier, more ancient. Every night would be a reminder of isolation, a black mirror reflecting the vastness of the universe. A moonless Earth would still be beautiful, but in a way that unsettles. The seas would shimmer with the sun's reflection, yet fall silent under the stars. The winds would carve continents, but never rest. Life might endure, even flourish, but under rules we could hardly recognize. The earth would spin, the oceans would whisper, and time would move forward. Yet something essential would be missing. A rhythm, a pulse, a quiet force that once made the chaos meaningful. Without the moon, the earth would still exist, but it would never truly feel alive. The moon has always been more than a light in the sky. It is the hidden engine that moves the waters of the earth. Its gravitational pull drags the oceans back and forth, raising tides that have shaped the surface of our planet for billions of years. That slow rhythm, the rise and fall, the constant motion, has sculpted coastlines, fed ecosystems, and guided life since its beginning. But in a world without the moon, that rhythm would vanish. The oceans would still respond to gravity, but only to the sun's far weaker tug, a fraction of what the moon provides. The tides would still exist, but they would be small, barely noticeable, a few inches where we now see meters, a soft lapping of waves where there should be surging floods. The difference seems small, but its consequences reach deep. On our real Earth, tides are more than moving water. They are the planet's pulse. They carry nutrients from the deep ocean to the shallows, stir oxygen into the depths, and mix the chemistry of life across the planet. Every tide reshapes the boundary between sea and land, creating temporary worlds that last only a few hours. Tidal flats, rock pools, and estuaries that come alive with every return of the sea. These fleeting environments are nature's testing grounds. They dry and refill, changing their temperature, chemistry, and salinity with each cycle. For early life, these constant fluctuations may have been essential. Scientists have long suspected that the earliest building blocks of life, amino acids, lipids, and proteins, needed such a rhythm. The repeated wetting and drying concentrated organic molecules, allowing them to form more complex structures. In tidal zones, simple chemistry became self-replicating biology. Without those cycles, the world becomes more static. There is no constant renewal, no repeated chance for molecules to meet and bond. Life might still arise in deep sea vents or within mineral pockets, but the diversity of conditions, that creative chaos that drives evolution, would be greatly reduced. A moonless Earth would not be lifeless, but its oceans would be quieter, less dynamic. The great conveyor belts of water that regulate the planet's temperature would move sluggishly. Without tidal energy to mix the layers, the seas might become stratified, warm and bright on the surface, cold and still below. In the deep, oxygen would run thin, nutrients would sink and remain trapped. Large stretches of the ocean could turn stagnant, silent deserts beneath the waves. Even if microbial life evolved, it would find fewer ways to spread. In our reality, the tides act as natural transport systems, scattering tiny organisms across the planet's coasts and estuaries. In their absence, life might remain isolated, confined to small pockets where conditions happen to be stable enough to endure. It's a quieter, slower form of evolution, patient but hesitant. The absence of strong tides would also reshape the continents themselves. Tidal erosion and sediment flow, processes that build beaches, shape deltas and carve bays, would slow to a crawl. Coastlines might remain sharper, more jagged, less welcoming to life. The gentle shifting sands and marshlands that cradle countless ecosystems today would barely exist. Rivers would still meet the ocean, but their mouths would not breathe in and out with the rhythm of the sea. Estuaries would be shallower, salt water would not reach as far inland, and many of the world's richest habitats might never form. The world's geography would still change, but more slowly. Less sculpted by water, more by fire and wind. If life ever reached the surface, it would face another challenge: timing. So much of what we consider natural rhythm, the migration of animals, the growth of plants, even the human sense of time, is tied to lunar cycles. The phases of the moon became nature's calendar. Without it, there would be no monthly rhythm, no celestial reminder of change. In a world without the moon, early life would grow under a simpler pattern. Day and night, light and dark, heat and cold. There would be no middle rhythm, no subtle transition between extremes. Evolution might still find its timing in other ways, perhaps by the temperature of the oceans or the pull of the sun. But the diversity and synchronization we see in nature today, from coral spawning to sea turtles nesting, might never evolve. The sea would be unpredictable, its cues inconsistent, its balance fragile. And then there is the human question. Though we have not yet entered the age of people in this thought experiment, if humanity ever emerged in such a world, the absence of tides would leave its mark not only on the landscape, but on the mind. There would be no gentle rhythm of the sea to inspire poetry or music, no visible link between the heavens and the oceans. The connection between sky and earth would be severed, an invisible bond lost before it was ever felt. The moon taught us to look upward, to connect what happens in the heavens with what happens below. Without it, perhaps we would never think to make that connection at all. A moonless earth would be quieter, but not peaceful. The stillness of the tides would be unnatural, a silence where there should be motion. The oceans would breathe more slowly, the world would change more reluctantly, and evolution itself might hesitate at every step. The tides gave Earth its heartbeat. Without them, the planet would still live, but faintly. Without the moon, Earth's oceans would settle into a haunting calm. The tides that once gave rhythm to life would fade into a faint whisper. The sun's distant gravity would still tug at the seas, but its pull is weak, only about a third of the moon's strength. The result would be barely perceptible tides, so small they might go unnoticed by any observer standing on the shore. The oceans would become slower, denser, less alive. In this new equilibrium, coastal ecosystems, the borderlands between sea and land, would be transformed. The vibrant wetlands, salt marshes and mangrove forests that depend on regular tidal flooding would struggle to exist. Their roots, once bathed in cycles of brackish water, would dry out. Without the constant exchange between fresh and salt water, estuaries would vanish or become static lagoons. The coast would lose its ever-changing nature, becoming fixed and unyielding. What was once a living edge between worlds would harden into permanence. For countless species, the disappearance of the tides would be catastrophic. Marine life evolved in lockstep with the lunar pulse. Crabs that scuttle to the beat of high tide, corals that spawn under a full moon, fish that migrate in tune with lunar phases. Without these rhythms, reproduction would become chaotic. Imagine coral reefs attempting to spawn without synchronization. Instead of millions of organisms releasing eggs and sperm in a single coordinated event, guided by moonlight, it would become scattered, inefficient and vulnerable. Predators would feast, populations would dwindle, marine biodiversity would crash, not because of a sudden extinction event, but because the rhythm that held ecosystems together would simply fade away. The darkness itself would also change. Nights without the moon would be far blacker, deeper than any night we know. On our moonlit Earth, animals evolved to use its glow for navigation. Sea turtles hatch at night and crawl toward the ocean by the reflection of the moon on the waves. Birds migrate under its light, using the glowing horizon as their guide. Without that subtle illumination, nocturnal life would lose its compass. The hatchlings, emerging from their sandy nests, might stumble inland instead of toward the sea, guided by false lights or the faint glimmer of stars. Predation would soar, and entire generations could vanish before reaching the water. For predators, the absence of moonlight would bring new opportunities and new dangers. The hunt would become an art of darkness. Sight would give way to sound, vibration, and scent. Species that depend on vision would decline, others would evolve to thrive in near total night. Over millions of years, evolution would sculpt new eyes and senses, sharper hearing, heightened sensitivity to electric fields, even bioluminescence as a substitute for moonlight. The seas might glow faintly from within, alive with organisms generating their own light to communicate, hunt, or lure prey. But the effects wouldn't stop at the water's edge. The absence of tides would also change the air above. On our moonlit Earth, the constant stirring of oceans helps regulate global temperatures, distributing heat from the equator toward the poles. Without it, temperature gradients would grow steeper. The tropics might become hotter and more stagnant, while the poles would freeze even deeper. This imbalance would reshape the jet streams and ocean currents, altering weather patterns across the planet. Hurricanes could become less frequent but more violent, fueled by trapped pockets of warm water that no longer circulate properly. Coastal winds, no longer influenced by the pull of rising and falling tides, would become unpredictable, reshaping the world's climate systems. Human civilization, if it ever emerged, would experience a very different kind of planet. Ancient people once used the tides as clocks, the moon as a calendar. Fishing, travel, agriculture, all were guided by lunar cycles. In this world, the sky would still hold stars, but no luminous companion would wax and wane above them. Nights would be truly dark, unsettlingly so. The myths of this world would never speak of a silver guardian watching over the earth. The ocean would not respond to the heavens. The link between sky and sea, between time and motion, would never be made. Without a moon, our ancestors might never have learned to measure time beyond the day. Months, derived from the lunar cycle, would have no meaning. Civilization's rhythm, its agriculture, festivals, and calendars might evolve entirely differently. Perhaps humanity would learn to count only by the sun's rise and fall, by the seasons rather than the phases of a celestial companion. Night would feel endless, mysterious, and dangerous, a realm not of reflection but of fear. On geological scales, the missing tides would even affect Earth's crust itself. The subtle flexing of the ocean floor, caused by tidal forces, relieves and redistributes pressure along tectonic boundaries. Without this gentle motion, stress would accumulate differently. Some regions might see fewer earthquakes and volcanic events. Others might grow more unstable as tension builds unchecked. The entire planet would feel the absence, not as a single event, but as a gradual stilling of motion. Earth without the moon would be a quieter world, but not a simpler one. It would be a planet where energy flows more reluctantly, where cycles slow and systems settle into uneasy equilibrium. Life would still adapt, but it would do so more cautiously. Bound by a world that changes too little, too slowly, the tides gave life a pattern, a breathing rhythm that mirrored the sky. Without that motion, evolution would lose one of its greatest teachers: repetition and renewal. The moonless Earth would still turn beneath the sun, but it would do so without song, without pulse, without the soft voice of the ocean calling and retreating with every passing night. The absence of the moon's gravity would silence not only the tides, but the planet's sense of motion itself, leaving a world where the sea never truly breathes again. The moon does more than light our nights. It holds the Earth steady. Its gravity acts like an invisible hand, a stabilizing anchor that prevents our planet from tumbling chaotically through space. Without it, the Earth's axis, that imaginary line around which the planet spins, would wander. It would tilt, sway, and drift unpredictably over thousands of years. Today, our axis tilts at about 23.5 degrees. That steady angle gives us the rhythm of the seasons. Spring's thaw, summer's heat, autumn's fade, and winter's rest. It's a delicate balance, one that has endured for hundreds of millions of years, because the moon keeps it so. But remove the moon, and the balance collapses. The Earth would become unstable. Its tilt could shift wildly, perhaps leaning as little as 0 degrees, or as much as 80. Imagine a world where the poles sometimes point directly at the sun, where ice caps melt completely one millennium, then rebuild into frozen continents the next. A planet caught in endless climatic whiplash. Without the moon's gravitational anchor, even small nudges from other planets, Jupiter, Venus, Mars, would push Earth's tilt into chaos. The change wouldn't happen overnight. It would unfold slowly, over thousands or even millions of years. But in geological time, that is a blink, and for life, it would be catastrophic. In some epochs, the tilt might flatten. The poles would receive almost no sunlight, locked in permanent twilight. Equatorial regions would lose their seasons entirely, a monotonous climate, hot and unmoving, broken only by storms that never end. In other eras, the tilt could swing far beyond anything we know. The Arctic could bask in tropical sunlight. Antarctica could bloom with forests. Meanwhile, the equator might freeze beneath relentless winters. The planet would lurch between extremes. Warmth and ice, drought and flood, with little warning. Civilizations, if they ever arose, would face endless upheaval. A single generation might see deserts where their ancestors once farmed. Another might watch glaciers return to bury entire continents. History would have no rhythm. Agriculture, trade, even migration would depend on a climate that could no longer be trusted. The sky itself would seem unpredictable. The stars, once fixed markers for navigation and myth, would shift slowly as the Earth's tilt changed its orientation to the cosmos. Constellations would drift from view. Calendars would fail. This instability would ripple far beyond weather. Ocean currents, the great engines that move heat across the globe, depend on temperature differences between poles and equator. As the tilt changed, those gradients would warp. Currents might stall, reverse, or disappear entirely. A planet in motion would lose its rhythm not only in the air, but in the deep. Entire ecosystems would collapse as marine life struggled to adapt to ever-shifting temperatures. The same oceans that once cradled life would now test its endurance. For the land, the consequences would be just as severe. Forests would die out, then reappear. Deserts would move like slow waves, swallowing and retreating across continents. In a span of only a few thousand years, a blink in geological time, Earth's surface could look entirely different. And with each cycle, species would have to evolve or vanish. Adaptation would become a race against instability. Survival would depend on flexibility rather than dominance. It's possible that life would endure. It always finds a way, but it would be restless. Few creatures could count on the same home for long. Habitats would appear and vanish like tides that no longer follow the moon. Even humans, if they ever emerged, would find themselves chasing the climate. Nomads forever, migrating with the seasons that refuse to stay still. Civilizations might rise and fall not from war or famine, but from the simple shifting of the planet's tilt. Empires would crumble as their lands froze or dried. Myths would be born from the sky's changing path. Perhaps whole religions would form around trying to predict where the sun would rise next century. The instability of the tilt would also alter the length of days over immense stretches of time. As the Earth wobbled, its rotation might speed up or slow down slightly. That change could seem small, seconds lost or gained per year, but over millions of years, it would reshape everything that relies on rhythm, the pace of wind, the spin of the oceans, the heartbeat of the planet itself, and all of it, every storm and shifting season, every wandering pole and crumbling forest would trace back to a single missing companion, the moon, gone. Without its gravitational hand to steady the Earth, our world would become a cosmic dancer without a partner. Beautiful, yes, but unbalanced, graceful in moments, yet doomed to stumble again and again. It's strange to think how something so distant, so silent, could be the reason our seasons feel predictable. The moon's stillness in the sky hides its true role, a guardian of stability, holding chaos at bay. Without it, the Earth would spin on, uncertain of where to lean, uncertain even of what it means to have a season. When the moon disappeared, Earth lost more than light. It lost the hand that kept its axis steady. And in that loss, the seasons became unpredictable, swinging between extremes with no warning. Ecosystems that once relied on gentle cycles of warmth and cold would face upheaval. Forests could blossom one century and be reduced to frost the next. Grasslands might thrive briefly, only to be swallowed by advancing deserts. Life would be forced into constant migration or extinction. Marine life would also pay a price. Ocean currents, driven by temperature gradients between poles and equator, would become erratic. Warm currents could stall, cold currents could surge unexpectedly. Nutrient distribution would become uneven. The rhythm of feeding and spawning, the pattern that supports entire food chains, would falter. Some species might survive by adapting quickly. Others would vanish, victims of instability that no evolution could fully anticipate. Extreme swings in climate would also influence the sky itself. Storms would become unpredictable. Hurricanes and cyclones could strike regions that once knew calm. Rivers could flood without warning. Coastal areas, already weakened by the absence of strong tides, would bear the brunt of these violent events. The moon once buffered Earth indirectly. Its pull slowed rotation, stabilized the tilt, and moderated atmospheric circulation. Without it, the winds themselves would act unpredictably, carving landscapes in patterns that repeat only in chaos. Even the equatorial regions would not escape. The tropics, usually hot and relatively stable, would experience sudden swings in temperature. One century might bring constant sun, dry and blistering. The next could bring prolonged rain or freezing conditions. Coral reefs, jungle ecosystems, and migratory animals would all be challenged to survive under such uncertainty. The diversity of life we know today may never have had the chance to evolve. Extinctions would occur in waves, punctuated by fleeting bursts of adaptation. Life would become a patchwork of fragile refuges, existing only where conditions happen to be tolerable at the moment. Human ancestors, if they emerged on such a planet, would face extraordinary challenges. Agriculture relies on predictability. Crops fail when seasons shift. Floods or droughts arrive without warning. Civilizations might rise in one generation and collapse in the next, driven not by conquest but by climate itself. Societies would become nomadic, moving constantly in search of reliable land. Trade and urbanization would be nearly impossible. Even the development of culture and knowledge might slow, constrained by a world in constant flux. The psychological impact of an unstable planet cannot be underestimated. Humans and other intelligent species thrive on patterns. Predictable seasons, stable skies, and regular day-night cycles give a sense of order. A planet that wobbles and swings, with winters that arrive centuries late, or summers that never end, would shape perception itself. Myths and religions might emerge around the chaos of the sky. Legends would describe the sun's unpredictable rise, the capriciousness of storms, and the incomprehensible patterns of weather. Civilization's earliest attempts to chart time might fail, leaving societies reliant on improvisation rather than planning. Volcanic activity and earthquakes might also shift under these conditions. The stress on the Earth's crust would vary as the axis changed. Regions that were once stable could become tectonically active. Volcanoes could erupt in new locations, reshaping landscapes and climate further. Mountains could rise and fall, coasts erode, and rivers redirect themselves, all in response to the planet's erratic wobble. The moon, though distant, acts like a stabilizer. Without it, the Earth's surface itself becomes unpredictable. Seasons, when they occur, would be extreme. Summers might scorch the poles while equatorial regions freeze. Winters could last centuries in one hemisphere while the other bakes in sunlight. This irregularity would limit biodiversity, as species would need extraordinary resilience to survive. Migration would be essential, but even migratory species might fail to anticipate the severity of environmental swings. Only the most adaptable, the most mobile, would endure. Life would still exist. The resilience of biology is remarkable, but it would be different. Complex ecosystems would struggle to stabilize. Animals would evolve heightened senses to detect subtle environmental changes. Plants would develop strategies to survive extremes. Yet even these adaptations could not fully compensate for the absence of rhythm, the absence of a stabilizing hand in the sky. The moon's disappearance would ripple outward in ways invisible at first glance. It does not just guide tides or illuminate nights, it preserves order in the spin of the planet. the tilt of its axis, and the gentle progression of seasons. Without it, the world becomes a place of extremes, a place where life endures but never rests, a planet forever shifting, forever uncertain, and forever searching for balance that may never come. Life on a moonless Earth would exist, but it would be forced into constant adaptation. The tides, once a reliable pulse, would fade. The seasons, once predictable, would swing without warning. The oceans would become quieter, and the air itself would be erratic. Every organism would face a world in flux. Every environment would be temporary, fleeting, and uncertain. Consider the oceans first. Without lunar tides, the shallow coastal zones that nurtured the first life would remain calm. Tidal pools, those cradles of early evolution, would be far less common. The chemistry of life, the concentration of molecules in wet and dry cycles, would slow. Complex structures might take far longer to form, and some might never appear at all. Marine species would need alternative strategies to survive. Organisms could evolve internal rhythms, biological clocks that compensate for the absence of lunar cues. Some might rely entirely on temperature changes, chemical gradients, or even magnetic fields to guide reproduction, feeding, and migration. Evolution would move more cautiously, driven by environmental extremes rather than steady patterns. Species that could quickly adapt to sudden swings in temperature, salinity, or water availability would thrive. Those that could not would vanish. Natural selection would favor versatility above specialization. In this world, survival would depend on the ability to endure chaos. A fish might need to tolerate months of still water and sudden floods. A plant might have to survive scorching sunlight one season and prolonged frost the next. Even simple organisms would evolve in ways that seem alien to us. Microbes might form colonies that can enter dormancy for decades, waiting for favorable conditions. Algae could adapt to thrive in stagnant waters, generating oxygen only when circulation temporarily returns. Coral-like species might develop internal mechanisms to reproduce without relying on synchronized mass spawning. Life would become ingenious, persistent, and relentless, but always under pressure. The absence of tides would also affect terrestrial ecosystems. Coastal wetlands and estuaries would be far less dynamic. Rivers might not deposit nutrients as widely without tidal backflow. Wetlands could shrink, leaving fewer habitats for amphibians, birds, and insects that rely on the delicate balance of salt and fresh water. Forest ecosystems would face instability as well. With a chaotic axial tilt, temperature swings could occur over centuries or millennia. Trees might grow faster to compensate for short favorable periods, then slow during sudden extremes. Species migration patterns would become more complex. Seeds would need to travel farther to reach suitable climates. Animals would need to follow, creating a constant flow of life across shifting landscapes. Predators and prey would evolve new strategies. Rapid climate swings could favor generalist predators capable of hunting in multiple habitats. Prey species might develop heightened senses, faster reflexes, better camouflage, or the ability to burrow or hibernate. The entire food chain would operate like a fragile balancing act, constantly adjusting to environmental unpredictability. Night would become a formidable challenge. Without the moon, darkness would be deeper and more complete. Nocturnal life would need to adapt to near total blackness. Eyes could evolve greater sensitivity, capable of detecting the faintest starlight or bioluminescent signals. Some species might evolve new methods of perception entirely, sonar, like echoes, electrical field detection, or chemical sensing. Predators could exploit darkness with greater efficiency, while prey species might become highly secretive or develop their own bioluminescent signals to communicate. Life would thrive in shadows, but always under pressure, always alert. On land, the impact of chaotic seasons would also shape behavior and physiology. Animals might develop flexible reproduction cycles, able to breed whenever conditions permit rather than on fixed seasons. Plants could evolve seed dormancy mechanisms that span decades, waiting for rare periods of warmth and moisture. Migration routes might shift continuously as climates fluctuate, creating a dynamic, ever-changing pattern of life across continents. The very concept of a stable habitat would be nearly impossible. No region would remain safe for long. The strongest survivors would be those capable of rapid movement, physiological flexibility, and behavioral innovation. Even intelligence itself might be shaped by chaos. Species capable of planning for unpredictable conditions could have an advantage. Problem solving, tool use, social cooperation, and foresight would become essential for survival. Life would reward those who could anticipate change rather than rely on rhythm. In such a world, civilizations, if they ever arose, would be constantly mobile. Permanent settlements might be impossible. Knowledge would be oral and adaptive, passed down with an emphasis on flexibility rather than rigid tradition. The interplay between sea, sky, and land would create constant pressure on life. Oceans that mix only weakly would limit marine food chains. Unstable climates would shift the distribution of forests, deserts, and ice. Nightfall without lunar light would push nocturnal life to extreme innovation. Yet life, as always, would endure. It would adapt to extremes rather than stability. It would invent ways to survive and even thrive, but in forms very different from our own Earth. The moon's absence is not just a missing celestial body. It is a missing stabilizer, a lost rhythm, a planet's pulse silenced. Life would continue, but it would follow a new pattern, one defined by resilience, adaptation, and survival in a world that constantly tests its limits. In this chaos, biology would become inventive and relentless. Species would find niches in which to hide, adapt, and multiply. Evolution would still occur, but it would be shaped by unpredictability, extremity, and constant pressure. Earth without the moon would not be lifeless. It would not be silent. It would be alive, but in a way that is unfamiliar, turbulent, and unsteady. Life on a moonless Earth would still find ways to endure. The challenges would be immense, but they would also drive innovation at every level. Creatures that could anticipate extremes, adapt quickly, or cooperate would dominate. Intelligence, in particular, could emerge as a survival advantage. Species capable of planning for unpredictable seasons, chaotic tides, and erratic climates would gain a crucial edge. Problem solving, memory, and communication would become essential tools, not luxuries. Marine life would continue its delicate adaptations. Without strong tides, reproduction would rely less on timing cues and more on environmental feedback. Species might develop chemical or electrical signaling to coordinate spawning. Migration could become instinct, driven rather than seasonally fixed, with marine animals sensing temperature, salinity, or magnetic anomalies to find optimal conditions. Even in shallow waters, life would adapt to extreme variability. Shorelines would change unpredictably as sea levels rose and fell slowly, or storms reshaped coasts. Creatures living there would need to move, hide, or endure until the next opportunity arose. On land, adaptation would follow similar patterns. Animals would evolve heightened awareness, flexibility in behavior, and resilience to rapid climatic shifts. Plants might develop extraordinary dormancy strategies, storing seeds, spores, or energy for decades to survive unpredictable seasons. Predation and competition would be relentless. Opportunistic species, those able to shift diets, habitats, or reproductive cycles, would dominate. Specialists might survive only in rare, stable microclimates. Social structures could arise as a response to environmental uncertainty. Cooperation would become critical for survival. Groups might share information about temporary refuges, food sources, or safe breeding grounds. Communication and collective planning would offer evolutionary advantages. In a moonless world, intelligence might not emerge in isolation. Species capable of collaboration, learning from each other and transmitting knowledge, would thrive where solitary life struggles. The absence of lunar light would profoundly shape nocturnal life. Species active in darkness would rely on senses beyond vision. Echo, location, heightened hearing, electric field detection, and bioluminescence could dominate nocturnal ecosystems. Predator-prey dynamics would become more complex, with adaptations evolving rapidly to outpace one another in the perpetual darkness. Over time, this could drive cognitive sophistication. Creatures navigating dark, shifting environments would require memory, pattern recognition, and problem-solving skills. The challenges of a moonless night could foster intelligence in ways that a stable, illuminated world does not. Evolution would also favor mobility and adaptability. Climate swings and axial instability would force species to migrate over long distances. Nomadic behaviors could become central to survival, those capable of sensing distant changes in weather, food availability, or habitat suitability would have a decisive advantage. In this world, movement itself becomes intelligence. Understanding patterns in chaos would be more valuable than brute strength or size. If human-like intelligence were to evolve, civilizations would differ profoundly from our own. Permanent settlements might be rare or impossible. Societies would need to move with environmental cycles, creating temporary clusters that shift over decades. Architecture, agriculture, and infrastructure would prioritize flexibility and mobility over permanence. Knowledge preservation would be critical. Without predictable seasons or stable coasts, oral traditions, adaptive education, and shared memory would govern survival more than written records. Innovation would thrive where rigid planning fails. Technology, too, would be shaped by chaos. Energy sources would need to be portable or adaptable. Food production would rely on species that can survive erratic climates. Communication systems, natural, chemical, or mechanical, would evolve to bridge distance across ever-changing landscapes. Social intelligence would become as important as mechanical intelligence. Cooperation would be rewarded, selfishness punished. Networks of survival would develop, extending the reach of intelligent species across continents and seas. The moonless sky would also influence culture, perception, and curiosity. Stars would shine brighter, but nights would feel infinite. Civilizations might develop a profound understanding of astronomy, not out of wonder, but necessity. Navigation, prediction, and the comprehension of chaotic patterns would shape thought. Religion and philosophy might emerge around the unpredictable Earth itself. Deities could be conceived not as creators, but as regulators of chaos, forces that bend storms, seasons, and tides. Knowledge would be sacred because survival depends on it. Even over millennia, Earth would remain a planet of extremes. Life would adapt, evolve, and persist, but its trajectory would differ dramatically from our own. Species capable of intelligence, cooperation, and mobility would dominate. Ecosystems would be transient, ever-changing, and fragile. The absence of the moon does not extinguish life, but it reshapes it. Evolution would be relentless, sculpting organisms capable of enduring unpredictability. The moon's stabilizing hand might be gone, but life would find new ways to persist. Over eons, Earth could produce creatures of extraordinary ingenuity, mobile civilizations, nomadic societies, and intelligent species finely attuned to environmental extremes might emerge. Their cultures, technologies, and social structures would be entirely defined by unpredictability. This is a world where chaos drives creativity, where intelligence is born from necessity, where life persists not in comfort, but in constant adaptation. The moon is more than a satellite. It is a guardian of rhythm, a stabilizer of cycles, and a silent architect of life's evolution. Without it, the Earth becomes a test of endurance. Yet life, stubborn, inventive, and relentless, continues. It finds ways to survive, to thrive, and to evolve under conditions we can barely imagine. A moonless Earth is not lifeless. It is not still. It is alive, but alive in chaos, forever shaped by the absence of the hand that once held it steady. Without the moon, nights would be profoundly dark. The familiar glow that once illuminated our world would vanish, leaving the sky scattered only with stars. The oceans, no longer pulled by lunar tides, would barely move. Coastal landscapes would lose their rhythm, and the subtle push and pull that nurtured marine life would fade into calm. Humanity, if it emerged at all, would confront a planet that is unpredictable, untamed, and immense. Seasons would no longer follow a reliable pattern. The Earth's axial tilt, unanchored by lunar gravity, could swing over centuries or millennia. The familiar cycle of spring, summer, autumn, and winter would become erratic. Regions that were once fertile could freeze, while deserts could bloom unexpectedly. Agriculture, the foundation of civilization, would struggle to adapt to such extremes. Food security would become a constant challenge. Societies might rely on nomadism or migrate to follow climates that permit life. Traditional settlements would be rare, as permanent structures could be destroyed or abandoned due to shifting weather patterns. Even the oceans, seemingly calm, would pose hidden dangers. Without strong tides to regulate currents, nutrient distribution would falter. Marine ecosystems would become fragile and unevenly productive. Fisheries might collapse in some regions while thriving in small pockets, creating patchy abundance and scarcity. The disruption of the oceans would ripple outward, affecting the atmosphere, climate, and even terrestrial life. Storms could become unpredictable and violent. Hurricanes and cyclones might strike regions that had never experienced them before. Flooding could occur without warning, reshaping coastlines and displacing life. Long-term geological processes would also be affected. The slight flexing of Earth caused by tides helps distribute stress along tectonic boundaries. Without it, earthquakes and volcanic activity might change in frequency and intensity. Some regions could become more stable, while others might experience unprecedented instability. The landscape itself would be reshaped, sometimes slowly, sometimes suddenly. Humans, if they existed in such a world, would need to develop unique strategies for survival. Mobility would be essential. Communities might form temporary settlements, shifting with the seasons or following available resources. Knowledge sharing would be critical, as no single generation could predict long-term environmental stability. Communication, collaboration, and foresight would define societies. Cooperation would become a survival trait, and intelligence would be measured not by conquest, but by adaptability. Even culture would be influenced by this unpredictable Earth. The absence of the moon's phases would eliminate a natural calendar. Festivals, rituals, and agricultural planning would rely on observation, improvisation, or mathematical prediction. Art, literature, and mythology might reflect the chaos of a world that never rests. The sky filled only with stars would inspire awe, but it could also instill a sense of uncertainty. Navigation would require ingenuity, as landmarks and celestial cues shift over centuries. Civilizations might become deeply attuned to environmental signals, temperature, ocean currents, and wind patterns to predict survival opportunities. Nightlife would transform dramatically. Without lunar illumination, nocturnal species would evolve extraordinary adaptations, eyes sensitive to minimal light, bioluminescence, and alternative sensory perception could dominate ecosystems. Predator-prey relationships would intensify, and ecological niches would shift continuously. Humans, if present, would also be affected psychologically. The absence of familiar nightlight could influence sleep patterns, perception of time, and cultural norms. The darkness would be absolute, and survival might depend on artificial illumination or natural adaptation to shadows. The moon's absence would also affect Earth's rotation and day length. Over millennia, the lack of tidal friction would allow the planet to spin slightly faster. Days could shorten by minutes or hours over evolutionary time, subtly reshaping the rhythm of life. Organisms would need to adapt their cycles of feeding, reproduction, and migration to match these shifts. The planet would remain dynamic, but in ways far less predictable than today. Chaos, rather than rhythm, would govern the environment. Life would not be extinguished, but it would be constantly tested. In such a world, adaptation would favor versatility over specialization. Species that can survive in multiple habitats, tolerate extremes, and respond quickly to environmental change would dominate. Life would persist in niches where instability is less severe, and extinction events would reshape ecosystems repeatedly. Human societies, if they evolved, would mirror this principle. Flexibility would define social structures, governance, and technology. Permanent cities might be rare, knowledge would travel with people. Culture would emphasize observation, innovation, and and improvisation. The long-term consequences extend beyond life itself. Without a moon, Earth's axis could eventually reach extreme tilts. Some areas would experience near constant sunlight, others near constant darkness. The distribution of ice, deserts, and forests would shift dramatically, and the planet's appearance would change over millennia. The moon's absence would be felt in every system: oceanic, atmospheric, biological, and even human. It is a silent architect, shaping life not with words, but with gravity. Earth without the moon would be alive, but in a different sense. The heartbeat of tides, the rhythm of seasons, and the cycles of the sky would be gone. Life would persist through adaptability, cooperation, and ingenuity. But every generation would face new challenges. Every ecosystem would shift, and every human society would be tested by the unpredictability of nature. The moon may be distant, but its influence is profound. Without it, Earth is not merely quieter, it is wilder, less forgiving, and more extraordinary in its survival. Over millions of years, the absence of the moon would reshape Earth on a planetary scale. Axial tilt swings could become extreme, pushing the planet into unpredictable climate cycles. Polar ice sheets might appear and disappear in rapid succession. Continents could alternate between arid deserts and lush forest. No single ecosystem would remain stable for long. Life would persist in fragmented refuges. Microbial colonies, hardy plants, and mobile animals would occupy niches where temporary stability allowed survival. Species with flexibility in reproduction, migration, and behavior would dominate. Specialized organisms would face continual extinction pressures. The oceans would reflect this instability. Without lunar tides, nutrient mixing would slow, creating stagnant regions and concentrated hotspots. Marine life would cluster in pockets where circulation allows sufficient oxygen and food. Some coastal areas could support thriving ecosystems, while vast stretches would become barren. Coral reefs, tidal flats, and estuaries, once teeming with life, might shrink or vanish entirely. Yet deep-sea ecosystems, less dependent on surface tides, could persist, adapting to extreme environmental shifts. The moon's absence would also intensify natural disasters. Unstable axial tilt could trigger sudden climate swings. Hurricanes, typhoons, and storms might strike unexpectedly, reshaping coastlines. Earthquakes and volcanic eruptions could become less predictable as tidal flexing disappears. Life would evolve to survive these extremes. Burrowing animals, mobile species, and organisms capable of dormancy would have an advantage. Intelligence and cooperation could emerge as critical tools for survival. Civilizations, if they developed, would exist in constant motion. Permanent cities would be rare, nomadic lifestyles might dominate. Agriculture would require adaptability, relying on resilient crops and flexible cultivation techniques. Trade and communication would depend on mobility and improvisation, rather than stable infrastructure. Social structures would emphasize cooperation. Knowledge transfer would be essential for survival, with learning and observation taking precedence over rigid tradition. Predictive skills, the ability to interpret environmental signals, would be as important as physical strength. Night would be profoundly dark. The absence of lunar illumination would push nocturnal life to evolve extraordinary adaptations. Enhanced vision, bioluminescence, and alternative sensory mechanisms could dominate the animal kingdom. Predator-prey dynamics would intensify in the deep darkness, driving rapid evolutionary change. Humans, if present, might develop tools or technologies to compensate for the lack of light. Artificial illumination could become central to safety, agriculture, and navigation. Cultural practices would reflect the constant negotiation with darkness and uncertainty. Over geological timescales, Earth's surface itself would continue to change dramatically. Extreme axial tilt could alter erosion patterns, river courses, and sediment deposition. Mountains might rise or collapse, ice sheets advance or retreat, and coastlines constantly shift. Life would be forced to follow these changes, migrating, adapting, or vanishing. Habitats would appear and disappear like islands in a chaotic sea. Evolution would favor speed, intelligence, and flexibility over specialization. Despite these challenges, life would endure. Resilient species would occupy ecological niches, developing adaptations never required on a more stable Earth. Intelligence could emerge as a survival tool, fostering cooperative strategies and technological innovation. Civilizations might be nomadic, but knowledge, ingenuity, and adaptability would allow culture to persist. The absence of the moon would also alter Earth's long-term rotational dynamics. Without tidal friction, the planet's spin would gradually accelerate. Days could shorten over millions of years, subtly reshaping the rhythms of life. Organisms and societies would need to adjust biological and cultural cycles to match new day lengths. Time itself would become fluid. Life would measure survival not in months or years, but in immediate adaptation to environmental extremes. The moon's silent influence on Earth is profound. It stabilizes the axis, governs tides, and preserves environmental rhythms. Without it, Earth becomes a planet of extremes, wild, unpredictable, and ever-changing. Yet even in chaos, life persists. Life's resilience would be its defining feature. It would endure heat, cold, drought, floods, and darkness. Intelligence, cooperation, and adaptability would shape survival. Every organism would navigate a world where predictability no longer exists. A moonless Earth is a reminder that stability is a gift. The moon quietly preserves the patterns that allow complex life to flourish. Without it, the planet is alive in a different way, dynamic, turbulent, and constantly testing the limits of life. Civilizations might exist, but they would be shaped by impermanence. Ecosystems would thrive in pockets, vanish in others, and evolve in unpredictable bursts. Life itself would become a story of endurance, ingenuity, and adaptation to a universe without the moon's guiding presence. The moon is more than a celestial object. It is an architect, a stabilizer, and a silent partner in the evolution of Earth. Without it, the planet endures, but under a new set of rules. Chaos drives survival, darkness drives innovation, and unpredictability becomes the only certainty. In the absence of the moon, life persists, remarkable, resilient, and forever reshaped by the loss of its silent companion. The moon's influence extends far beyond Earth's tides and nights. It acts as a stabilizer, not only for our planet's axis, but also for its orbit around the sun. Without it, Earth would become more vulnerable to subtle gravitational nudges from other planets. Over millennia, these small forces could accumulate, altering the shape and orientation of Earth's orbit. A slightly more elliptical orbit would mean extreme temperature swings. Summers might become scorching in some centuries, while winters plunge regions into unexpected glaciation. Life, already challenged by chaotic seasons, would be forced to adapt again, this time to entirely new cycles. The moon also affects Earth's rotation. Without tidal friction, the planet would gradually spin faster. Days might shorten by hours over millions of years. The shortening of days would impact biological rhythms, weather patterns, and even ocean currents. Organisms and ecosystems would need to evolve strategies to cope with faster cycles. Earth's axial wobble, now unchecked, could amplify these effects. A planet that tilts and sways unpredictably experiences radical climate shifts. Polar regions might tilt toward the sun for centuries, melting ice sheets and flooding continents. Equatorial zones could freeze under extreme tilt. The absence of the moon would even alter the planet's magnetic environment. Though the moon does not generate its own magnetosphere, its presence stabilizes tidal flows in the core. Without this subtle influence, the liquid outer core's flow could become more chaotic. Magnetic field fluctuations might occur, affecting atmospheric retention and radiation shielding. Life on the surface could experience increased cosmic radiation during periods of weaker magnetism. Earth's position within the solar system would also subtly shift. Jupiter, Venus, and Mars exert constant gravitational pulls on our planet. With no moon to help stabilize the tilt and orbit, these nudges could accumulate over millions of years. This might slightly alter the timing of seasons, the path of comets, or even the frequency of meteorite impacts. A world without the moon would not only be more dynamic, it would also be more exposed. Impacts from space, already rare but catastrophic, could have more pronounced effects on an unstable planet. Even a small asteroid could strike with greater consequences if the Earth's axial tilt and rotation amplify secondary effects like storms or tsunamis. The oceans, already weakened without tidal motion, would compound these effects. Storm surges and flooding could be intensified by unpredictable currents. Coastal ecosystems, already fragile, would struggle to recover from the combined stress of tides, storms, and temperature extremes. Marine life, dependent on cycles and currents, would face heightened survival pressures. Beyond immediate planetary effects, the absence of the moon could influence Earth's long-term habitability. Stable climates support complex life, and by extension, intelligence. Without this stabilizing companion, evolutionary pressures would intensify. Only species capable of navigating chaos, mobile, adaptive, and resilient, would survive. Civilizations, if they arise, would be small, mobile, and highly resourceful, forever shaped by unpredictability. The moon also shields Earth from cosmic debris to some extent. Its gravitational field pulls or deflects small objects that might otherwise collide with the planet. Without it, Earth could experience slightly higher frequencies of impacts over geological time. Even tiny meteoroids might pose new hazards for life and civilizations. The interplay of these forces, orbital shifts, rotation changes, axial wobble, weakened magnetic field, and reduced lunar shielding, creates a planet in constant motion. The moon's absence is not only a loss of light and rhythm, but also a removal of cosmic stability. Earth's surface and life would reflect this instability. Ecosystems would be fragmented, species distributions would be irregular, and evolutionary paths would become more experimental and unpredictable. Life would persist, but in forms molded by a world that constantly tests the boundaries of adaptation. Human understanding of the sky would also be fundamentally altered. Without a moon, celestial navigation would be more complex. Calendars would rely solely on the sun and stars, both of which shift gradually over millennia due to orbital variations. Civilizations might develop sophisticated predictive sciences to anticipate environmental extremes, tracking subtle cues in the solar system itself. Societies capable of interpreting cosmic rhythms would have a survival advantage. Knowledge, observation, and communication would replace permanence and stability as the foundation of civilization. Even the night sky would be transformed. Without the moon's glow, stars would appear brighter, but the familiar patterns would slowly drift over millennia. Life evolved to rely on lunar illumination. From turtle hatchlings to nocturnal predators would adapt or perish. The absence of the moon would force new methods of perception, navigation, and social coordination. Over ions, Earth would endure as a dynamic, unpredictable planet. Its climate, ecosystems, and life forms would continually adjust to instability, never finding a fixed balance. Evolution would favor innovation over tradition, mobility over permanence, intelligence over brute strength. A moonless Earth would be a place where chaos drives survival, adaptation, and even creativity. The absence of a single celestial companion would ripple outward, shaping the planet, its life, and the very fabric of civilization itself. Over the span of millions of years, Earth without its moon would continue to evolve into an unpredictable world. Axial tilt swings could become extreme, causing entire continents to alternate between tropical heat and frozen wastelands. Ice ages might come and go in irregular cycles, melting and reforming ice sheets across polar and mid-latitude regions. Life would need to adapt continuously, thriving in temporary refuges while other species vanish entirely. The oceans would feel these changes acutely. Without lunar tides to mix waters and regulate currents, nutrient flow would become uneven. Some regions might turn into stagnant zones, limiting biodiversity. Other areas would develop localized pockets of productivity, sustaining dense populations of adaptable marine organisms. Coral reefs, mangroves, and tidal wetlands, once keystones of coastal ecosystems, would face dramatic reductions. Life that depends on predictable tides and cycles would either adapt to these new patterns or face extinction. Shallow seas might become unpredictable deserts, while deep oceans retain pockets of relative stability. Earth's rotation would also slowly accelerate without tidal breaking from the moon. Shorter days would influence weather patterns, ocean circulation, and biological rhythms. Organisms would evolve to fit these faster cycles, adapting feeding, breeding, and migration schedules to match the new rhythm of life. Axial wobble would further destabilize the climate. Polar regions could be pointed toward the sun for centuries, while equatorial areas freeze. Seasonal extremes would intensify, creating unpredictable agricultural and ecological conditions. Planetary interactions would add additional complexity. Gravitational tugs from Venus, Jupiter, and Mars would subtly affect Earth's orbit. Slight variations could amplify climatic extremes over millions of years. The planet might swing closer or further from the Sun during certain millennia, producing temperature variations far beyond anything we experience today. Even meteor impacts could become more consequential. Without the Moon's gravitational shield, small comets and asteroids might strike more frequently, occasionally reshaping landscapes and affecting entire ecosystems. Life on a moonless Earth would be defined by adaptability and mobility. Species capable of responding rapidly to environmental extremes would dominate. Nomadic patterns would emerge both on land and in the oceans. Intelligence would provide a significant advantage, enabling creatures to anticipate danger, locate resources, and cooperate to survive. Even human-like intelligence could arise, but civilizations would be mobile, decentralized, and resilient. Communities might develop portable infrastructure, adaptable food systems, and flexible governance to withstand the unpredictable world. The absence of lunar light would reshape nocturnal ecosystems. Predators and prey would evolve extraordinary adaptations to navigate total darkness. Enhanced vision, bioluminescent communication, and alternative sensory perception could dominate ecological strategies. The night would become a crucible for innovation, driving evolutionary pressures in ways our current world does not. Humans, or intelligent life with similar needs, would need to create new forms of artificial illumination or develop natural adaptations to function in darkness. Cultural practices, mythology, and social coordination would reflect a world where night is absolute. Geological processes would also respond to this instability. Extreme axial tilts could reshape river systems, accelerate erosion, and alter sediment deposition patterns. Volcanoes and earthquakes could shift in frequency and intensity, creating landscapes in constant flux. Habitats would form and vanish repeatedly, favoring species capable of rapid adaptation or migration. Life itself would become a testament to persistence. Evolution would reward versatility, mobility, and intelligence above specialization. Extinction would be frequent, but innovation would drive the emergence of new forms of life, continuously reshaping ecosystems. Over eons, Earth could evolve into a world of fragmented habitats. Survival would favor nomadic and cooperative species. Complex life would exist in isolated pockets, connected by networks of migration and adaptation. Civilizations, if they emerged, would prioritize mobility, knowledge sharing, and predictive skills to navigate a world of extremes. Even the solar system itself would shape survival. Earth's orbit, influenced by other planets and destabilized by the Moon's absence, could cause periodic environmental crises. Life would need to anticipate these cycles, even when they span millennia or face extinction. Ultimately, a moonless Earth would endure as a planet defined by unpredictability. The familiar rhythms of tides, seasons, and stable nights would be gone. In their place would be extremes, chaotic, violent, and ever-changing. Yet life would persist, continually adapting, innovating, and evolving. Civilizations might exist, but their structures, cultures, and technologies would reflect impermanence and resilience. Ecosystems would be transient, shifting with climate swings and geological upheavals. The absence of a single celestial companion would shape the evolution of life, intelligence, and society in ways we can barely imagine. A moonless Earth reminds us how vital our natural satellite is. It is not just a glowing presence in the night sky. It is a stabilizer, protector and silent architect of life's rhythm. Without it, the planet endures, but under a new set of rules, chaos governs, survival depends on adaptability, and unpredictability becomes the only certainty. Life persists in this wild, untamed environment, shaped by challenges that would seem unimaginable to modern eyes. The moon's absence transforms Earth into a place where only the adaptable, the intelligent, and the resilient can endure. Without the moon, Earth is a planet of extremes. The rhythmic cycles that guide life, tides, seasons, and even the gradual slowing of rotation would be gone. Chaos would replace stability, and unpredictability would define every environment. From the smallest microbe to the largest predator, life would be shaped by constant adaptation. Species capable of rapid behavioral and physiological adjustments would thrive, while those relying on consistency would vanish. The moon's absence reverberates through every ecosystem, every ocean current, and every terrestrial habitat. Human perception, if humans existed, would also be transformed. The familiar night sky would lose its anchor. No lunar glow would soften the darkness, no phases to mark the passage of time. Calendars and rituals, once guided by the moon, would rely solely on the sun, stars, and careful observation of the planet itself. Civilizations would prioritize knowledge, foresight, and cooperation. Permanence would be rare, and mobility would define societal survival. The absence of a stabilizing lunar presence would force ingenuity at every level, from agriculture to architecture, from navigation to cultural continuity. Even the oceans would reflect this change. Without lunar tides, coastal ecosystems would be static or fragmented. Nutrient cycling would be uneven, affecting fish populations and marine productivity. Organisms dependent on tidal rhythms for reproduction or migration would either adapt to new cues or face extinction. The subtle, persistent rhythm that once allowed marine life to flourish would vanish. Axial tilt would become unpredictable. Seasons could swing between extremes over centuries or millennia. Polar regions might bake under extended sunlight or freeze in prolonged darkness. Equatorial regions could experience sudden cold snaps or unexpected heat waves. Life would need to respond to conditions that are neither reliable nor forgiving. The moon acts as a stabilizer of the planet's wobble. Without it, Earth would tilt erratically, making long-term climate forecasting nearly impossible. Organisms and civilizations alike would need to evolve flexible strategies for survival. Even nightlife would face extraordinary challenges. No lunar illumination would make darkness deeper and more complete. Nocturnal animals would evolve heightened senses, bioluminescence, or alternative perception systems to navigate their world. Predator-prey interactions would intensify, driving rapid evolutionary innovation. Human-like species, if present, would need to innovate. Artificial light, adaptive technologies, and observational skills would become essential. Society would evolve to operate under extreme uncertainty, with survival hinging on intelligence, foresight, and cooperation. Over geological time scales, the consequences expand further. Earth's rotation would gradually accelerate without lunar tidal braking. Days could shorten, reshaping biological and cultural rhythms. The planet's orbit and axial tilt would be more susceptible to perturbations from other planets. Meteor impacts, once mitigated slightly by the moon's gravity, could strike more frequently or with greater consequences. Earth's surface, oceans, and atmosphere would continually respond to these instabilities. Rivers, mountains, and coastlines would shift over time. Habitats would appear and disappear unpredictably, and ecosystems would be fragmented. Life's resilience would be tested constantly. Versatility, mobility, and adaptability would become essential traits. Species that thrive in this chaotic environment would evolve behaviors, morphologies, and intelligence far different from those on a stable, moonlit Earth. Civilizations, if they emerged, would reflect these principles. Mobility, cooperation, and knowledge sharing would be paramount. Culture, technology, and governance would evolve to manage uncertainty rather than exploit stability. Survival would not be about conquest or permanence. It would be about adaptation and foresight. The moon's influence extends even to the perception of time and space. Its phases, regular and predictable, have guided humans for millennia. Without it, orientation in the night sky would be harder, and the cycles of life and culture would require new methods of measurement. The absence of a guiding celestial body would profoundly affect both practical navigation and the human sense of place in the universe. Ultimately, a moonless Earth would be alive, but differently. Life would endure in niches, ecosystems would be patchy, and civilizations would be transient. Chaos, not rhythm, would shape survival, innovation, and intelligence. The moon is a silent stabilizer. Its absence demonstrates how one celestial companion influences an entire planet. Without it, Earth would remain beautiful and vibrant, yet perpetually uncertain. Life would persist, but it would be defined by flexibility, resilience, and a constant negotiation with the unpredictable. In losing the moon, Earth does not lose life, but it gains a new rhythm, one of challenge, adaptation, and relentless survival. Without the moon, Earth would endure chaos on every scale, from fluctuating seasons to unstable climates, from darkened nights to unpredictable tides. Every aspect of the planet would be altered. Yet life would persist, constantly adapting to the challenges imposed by the absence of its lunar companion. The moon's presence has allowed life to develop within a predictable framework. Cycles of tides and seasons gave organisms the stability necessary to evolve complex behaviors, reproduce reliably, and develop intricate ecosystems. Without this stability, evolution would favor versatility, mobility, and rapid adaptation above specialization. The oceans, once the cradle of life, would lose their rhythm. Marine ecosystems would be patchy and irregular. Shallow coastal regions, previously enriched by tidal mixing, would stagnate. Deep oceans might retain isolated pockets of stability, but the intricate networks of marine life we know today would be altered drastically. Life on land would also feel the moon's absence. Axial tilt variations would produce extreme climate swings, with regions experiencing alternating deserts, forests, and ice ages over millennia. Migration and adaptation would be essential for survival. No species could rely on stability. Flexibility would define evolutionary success. Civilizations, if they arose, would be profoundly different. Human-like intelligence would emerge under pressure, emphasizing cooperation, knowledge sharing, and innovation. Settlements would likely be temporary and mobile, moving with shifting climates and resources. Architecture, agriculture, and technology would be designed to endure change rather than rely on permanence. Societies would develop a heightened awareness of the natural world. Observation, prediction, and adaptation would replace tradition as the guiding principle of culture. Without a stabilizing moon, humans would cultivate a relationship with uncertainty, learning to anticipate, improvise, and survive. Even the night sky would be transformed. Without lunar light, darkness would dominate, creating challenges for nocturnal life and human activity. Eyes and behaviors would adapt to perceive subtle starlight, bioluminescence, or other environmental cues. Life would evolve new strategies to communicate, navigate, and thrive in near total darkness. This absence also alters perception itself. The moon has guided humans for millennia. Calendars, rituals, stories, and myths all reference its presence. Without it, the human imagination would find new anchors in the stars, the sun, and the patterns of an ever-changing Earth. Geologically, the planet would evolve differently. Rotation would accelerate without tidal breaking, altering day lengths and circadian rhythms. Axial wobble could reach extreme angles, dramatically shifting climates over centuries and millennia. Tectonic and volcanic activity might respond subtly to the absence of lunar influence, reshaping continents, mountains, and coastlines. Life and intelligence would navigate this shifting landscape. Organisms would migrate, hibernate, or evolve dormancy to survive periods of extreme stress. Species capable of rapid behavioral flexibility would dominate ecosystems. Intelligent life would rely on foresight, cooperation, and innovation to endure. Philosophically, the absence of the moon invites reflection on the fragility and resilience of life. A single celestial companion has profound effects, from stabilizing climates to influencing biological rhythms. Its disappearance illustrates how interconnected cosmic forces shape the evolution of life and the development of civilizations. Earth would not be lifeless, but its story would be rewritten. Life would adapt to chaos, intelligence would emerge under pressure, and civilizations would be mobile, flexible, and resourceful. Existence itself would be a constant negotiation with unpredictability. In many ways, a moonless Earth highlights the extraordinary balance that sustains life. The moon is a stabilizer, protector, and silent architect. Its presence allows oceans to pulse, seasons to flow, and life to evolve with remarkable consistency. Without it, the planet is alive, but alive in a turbulent, demanding, and unpredictable way. The moon shapes not only Earth's environment, but also the evolution of intelligence. Organisms capable of cooperation, adaptation, and innovation would thrive, while those dependent on stability would falter. Civilizations would be defined by mobility, flexibility, and a deep understanding of environmental cues. Ultimately, the moon's absence teaches a profound lesson. Life does not merely endure in a moonless world, it transforms. Species adapt, ecosystems shift, and intelligence finds new strategies to survive. Chaos becomes a teacher, unpredictability a catalyst for creativity, and survival a testament to resilience. Even without its lunar companion, Earth would remain vibrant and alive. Every creature, from microbe to civilization, would reflect the pressures and opportunities of a world unbound by lunar stability. The absence of the moon magnifies the remarkable ability of life to persist, innovate, and flourish under extreme conditions. Without the moon, Earth's history unfolds in turbulence and adaptation. Seasons are irregular, tides minimal, and nights profoundly dark. Life evolves under pressures that constantly test flexibility, mobility, and intelligence. From microscopic organisms to intelligent species, every form of life adapts to a world that offers no predictable rhythm. The oceans, once governed by tidal patterns, would become unpredictable arenas. Marine ecosystems fragment into regions of abundance and scarcity. Species reliant on tidal cues for reproduction, feeding, or migration would either innovate new survival strategies or disappear entirely. Coral reefs, estuaries, and tidal wetlands shrink, but life persists in pockets of stability. Deep-sea ecosystems could offer long-term refuges, relatively insulated from surface chaos. Here, bioluminescence, chemical communication, and adaptive hunting strategies dominate. Life evolves under selective pressures not present in our moon, stabilized oceans, driving innovation at every level. On land, climate instability becomes a defining force. Axial tilt variations produce extremes, sudden ice ages, scorching summers, unexpected droughts, and floods. Regions previously fertile may become deserts, while arid zones bloom temporarily. Life adapts through mobility, hibernation, dormancy, and flexible reproductive strategies. Migration is essential. Species traverse vast distances to follow habitable zones, exploiting temporary conditions. Extinctions occur frequently, but adaptive survivors emerge in response to each new environmental challenge. Human-like intelligence, if it evolves, would also be shaped by these extremes. Civilizations would be mobile, decentralized, and resilient. Knowledge transfer becomes critical for survival. Permanent settlements would be rare. Agriculture, infrastructure, and technology would emphasize adaptability rather than permanence. Societies would depend on observation and prediction. Environmental signals, subtle celestial movements, and seasonal anomalies would guide decisions. Cooperation, foresight, and ingenuity would become central to survival, replacing traditional hierarchies and rigid planning. The night sky itself is transformed without lunar illumination. No moonlight softens the darkness, making nocturnal survival more challenging. Predator-prey dynamics intensify, forcing rapid adaptation in hunting, navigation, and communication. Organisms might develop extraordinary sensory systems, enhanced vision, echolocation, bioluminescence, and chemical signaling. Human-like species would need to develop new technologies for illumination, navigation, and resource management. Artificial light would become essential for safety, agriculture, and social coordination, culture would adapt to a perpetual darkness, influencing art, mythology, and rituals. Over geological timescales, the absence of the moon reshapes the planet fundamentally. Earth's rotation gradually accelerates, shortening days and altering circadian rhythms for all life forms. Axial wobble intensifies, producing extreme climate swings over centuries or millennia. Tectonic and volcanic activity responds to these new dynamics, reshaping continents, mountain ranges, and river systems. Habitats constantly change. Ecosystems form and vanish repeatedly, fragmenting life into isolated pockets. Extinction events are frequent, but innovation persists. Evolution favors adaptability, intelligence, and mobility above size, strength, or specialization. The moon also serves as a shield against cosmic debris. Without its gravitational influence, Earth is slightly more exposed to impacts from asteroids and comets. Even small meteoroids could cause disproportionate consequences in a world already destabilized by axial shifts and climate extremes. Life evolves in constant awareness of both terrestrial and extraterrestrial hazards. Social structures in intelligent species reflect these pressures. Cooperation becomes a survival trait, shaping group dynamics, communication, and culture. Nomadic civilizations develop portable infrastructure and resilient technologies. Knowledge, prediction, and adaptation define the longevity of societies more than wealth or power. Cultural evolution mirrors environmental unpredictability. Mythology and philosophy arise from direct engagement with survival challenges. Stories emphasize resilience, flexibility, and the ability to anticipate or improvise in a changing world. Planetary instability also affects human perception and scientific development. Calendars, navigation, and long-term planning require constant observation and adaptation. Civilizations develop sophisticated predictive sciences, tracking celestial movements and environmental cycles. Astronomy, meteorology, and environmental studies become essential tools for survival. The moon's absence transforms how intelligence interacts with the universe. Instead of relying on predictable lunar cycles, civilizations must learn to interpret chaotic signals and adapt strategies in real time. Knowledge becomes a tool for survival rather than curiosity. Over millions of years, Earth without the moon becomes a testament to resilience. Life endures through migration, dormancy, and cooperation. Civilizations, if they arise, are shaped by impermanence, mobility, and adaptability. Ecosystems evolve in fragmented, shifting patterns, creating a patchwork of biodiversity and evolutionary experimentation. Intelligence itself might evolve differently. Cognitive abilities could emphasize foresight, memory, communication, and environmental interpretation. Survival requires anticipating unpredictable changes in climate, terrain, and celestial influences. Ultimately, a moonless Earth illustrates the delicate balance that governs planetary life. The moon stabilizes rotation, tides, and axial tilt, providing an environment conducive to the evolution of complex life. Without it, chaos dominates, but life persists through ingenuity and adaptation. Life's resilience becomes its defining feature. Species evolve to survive extremes. Intelligence arises as a tool for managing unpredictability. Civilizations, ecosystems, and even planetary processes reflect the constant interplay of instability and survival. Over millions of years, the absence of the moon leaves a profound mark on the planet. Axial tilt swings grow increasingly unpredictable, reshaping climate zones over centuries and millennia. Regions that were once temperate may experience scorching heat or perpetual cold. Deserts may blossom into forests temporarily, only to vanish again as conditions shift. Life adapts to this unpredictability. Species capable of rapid migration, flexible reproduction, and behavioral innovation dominate ecosystems. Those relying on consistency face repeated extinction. Even intelligent life must remain mobile, adaptive, and highly observant to survive. The oceans continue to reflect the moon's absence. Without tidal forces, nutrient cycling becomes irregular. Marine life clusters in productive pockets, leaving other regions barren. Shallow coastal ecosystems, coral reefs, estuaries, tidal flats, shrink or vanish. Deep sea life may flourish, relying on chemical and environmental cues rather than surface-driven cycles. Predator-prey dynamics evolve under new pressures. Bioluminescence, echolocation, and chemical signaling could dominate communication and hunting. Intelligent life, if present, develops tools to navigate, illuminate, and understand the darkness of moonless nights. Geological and planetary processes become increasingly dynamic. Earth's rotation accelerates without lunar braking, shortening days over millions of years. Axial wobble induces extreme climate swings, flooding continents, and freezing equatorial zones unpredictably. Tectonic activity, responding to these new dynamics, reshapes mountains, valleys, and coastlines. Habitats form and disappear repeatedly. Life must migrate, adapt, or perish with each transformation. Extinction is frequent, but innovation ensures continuous evolutionary experimentation. The moon's absence also exposes Earth to cosmic influences. Without its gravitational shielding, small asteroids and comets may strike more frequently. Even minor impacts could trigger cascading effects in already unstable climates. Life evolves under constant pressure, developing strategies to survive both terrestrial and extraterrestrial threats. Intelligent species would need foresight and predictive capabilities to survive these hazards. Knowledge, observation, and innovation become the foundation of culture and society. Civilizations adapt to a world where permanence is rare, mobility is essential, and survival depends on understanding a chaotic environment. Cultural and philosophical evolution would mirror environmental challenges. Stories, rituals, and art would center on resilience, adaptation, and the unpredictability of life. Intelligence would be measured by problem solving, cooperation, and anticipation rather than accumulation of resources or conquest. Societies would value foresight and flexibility above permanence and rigidity. Astronomical observation would also be transformed. Without a moon, celestial navigation relies on the sun, stars, and planets. Tracking environmental cycles becomes essential for survival. Predictive sciences, astronomy, meteorology, and environmental modeling become crucial cultural tools. Intelligent life learns to interpret chaotic signals. Observation replaces tradition, improvisation supplants routine, and adaptation defines survival. The moon's absence cultivates creativity, resilience, and ingenuity as essential traits. Overall, Earth becomes a dynamic mosaic of life and civilizations. Ecosystems evolve rapidly, forming and disappearing across the planet. Species occupy fragmented niches, with evolution experimenting continuously. Civilizations, if they arise, are mobile, adaptable, and deeply attuned to environmental signals. The absence of the moon amplifies the interconnection of life and environment. Survival is not guaranteed by stability, but by the ability to respond to shifting conditions. Adaptation, intelligence, and cooperation become fundamental to life on every scale. In the distant future, Earth's fate would continue to diverge from our moon's stabilized reality. Axial tilt swings could become extreme, creating periods of near perpetual sunlight or darkness in different regions. Climate zones could shift unpredictably, altering the distribution of oceans, deserts, and forests. Life persists, but it is forever shaped by the pressures of instability. Civilizations would evolve to navigate this unpredictability. Mobility, resourcefulness, and foresight dominate cultural values. Knowledge and prediction become survival tools, guiding agriculture, migration, and societal planning. Traditional permanence is replaced by adaptability and improvisation. The moon's absence is also a philosophical lesson. It demonstrates how one celestial body can shape an entire planet's environment, evolution, and the emergence of intelligence. Without it, Earth endures chaos, yet life demonstrates remarkable resilience. The planet's story becomes one of constant challenge, adaptation, and reinvention. Life thrives not by stability, but by flexibility. Species evolve to survive extremes, ecosystems shift continuously, and civilizations reflect a world in perpetual motion. The moon's absence underscores the fragility and resilience of life simultaneously, reminding us of the delicate balance that allows complex ecosystems and intelligent life to flourish. Even in this moonless world, beauty remains. The night sky is darker, yet filled with brighter stars, alien constellations, and distant galaxies. Landscapes transform unpredictably, creating ever-changing patterns of forests, deserts, rivers, and mountains. Oceans pulse in irregular rhythms, offering glimpses of continuity in an otherwise unstable world. Life adapts creatively, forming strategies and behaviors that are unique, innovative, and resilient. Civilizations, if present, are mobile and flexible, guided by observation and ingenuity. Every organism becomes a testament to persistence, innovation, and the enduring drive to survive. Throughout history, humans have looked to the moon as a constant companion. Its presence is so familiar that its influence often goes unnoticed. Yet, without it, Earth would be unrecognizable, a world of extremes, unpredictability, and constant adaptation. The moon stabilizes the Earth's axial tilt, governing the seasons and allowing life to flourish within a predictable rhythm. Without it, axial wobble would be extreme, producing radical climate swings over centuries and millennia. Polar ice caps might melt under prolonged sunlight, only to expand suddenly when the axis tips in the opposite direction. Equatorial regions could freeze unexpectedly, creating cycles of survival that demand rapid adaptation. Life would respond to these challenges with remarkable ingenuity. Species capable of mobility, behavioral flexibility, and rapid reproduction would dominate ecosystems. Specialized organisms would face repeated extinction, while adaptable species would evolve new strategies for survival. Even intelligent life would reflect these pressures, evolving societies and technologies suited to constant change. The oceans, once governed by lunar tides, would transform dramatically. Tidal flats, estuaries, and coral reefs, essential to marine biodiversity, would shrink or vanish. Nutrient cycling would be irregular, creating fragmented regions of abundance and scarcity. Deep sea ecosystems, less dependent on surface cycles, might persist, evolving complex adaptive strategies to survive in isolation. The moon also acts as a partial shield against cosmic debris. Without its gravitational pull, Earth is more exposed to meteoroids and comets. Even small impacts could have catastrophic consequences in a world already destabilized by axial shifts and climate extremes. Life would evolve not just in response to environmental unpredictability, but also under the constant threat of extraterrestrial hazards. Intelligent species, if present, would require foresight and innovation to survive. Knowledge of celestial patterns, environmental cues, and planetary behavior would be central to culture and governance. Permanent settlements would be rare. Mobility and adaptability would define civilizations. Architecture, agriculture, and technology would emphasize resilience over permanence. The absence of lunar light would reshape nocturnal life. Predators, prey, and humans alike would need extraordinary adaptations to navigate total darkness. Enhanced vision, echolocation, bioluminescence, and chemical communication could dominate ecosystems. Artificial illumination and predictive strategies would become essential for human-like civilizations. Culture, mythology, and social practices would evolve around the perpetual darkness of nights without the moon. Over geological timescales, Earth itself would evolve differently. Shortened days, accelerated rotation, and fluctuating climates would alter the development of life. Habitats would form and vanish repeatedly, creating dynamic evolutionary pressures. Species would adapt, migrate, or vanish, while intelligence, creativity, and cooperation would become the most critical traits for survival. Civilizations, if they emerged, would reflect this reality. Mobility, foresight, and adaptability would be central to their structure and culture. Knowledge would replace tradition as the cornerstone of society. Innovation, rather than permanence, would define their ability to endure over centuries and millennia. Philosophically, the absence of the moon offers profound reflection on the delicate balance of life. One celestial body influences climate, tides, ecosystems, and the emergence of intelligence. Without it, life persists, but under a different set of rules. Chaos, uncertainty, and adaptation become constants. The moon's presence demonstrates how interconnected and finely tuned planetary systems truly are. Even small influences, like tidal mixing or axial stabilization, shape the possibilities of life. The absence of the moon magnifies the resilience of species, the adaptability of ecosystems, and the ingenuity of civilizations. It underscores the idea that stability is not a given, but a gift, and that life endures through constant negotiation with its environment. The moon also shapes human imagination, culture, and perception. Its phases guide calendars, rituals, and art. Its glow illuminates the night, inspiring myths and science alike. Without it, celestial navigation would rely solely on the stars and the sun. Humanity's understanding of the cosmos would take a different path, guided by observation, prediction, and survival rather than familiarity. Civilizations would become intimately connected to the planet's cycles, tracking axial shifts, climate patterns, and celestial events to endure. Innovation, observation, and cooperation would define culture, replacing permanence and predictability. The moon's absence is not simply a loss of beauty, but a reshaping of life, society, and perception. Ultimately, a moonless Earth is a testament to resilience. Life adapts to extremes, ecosystems evolve under unpredictable pressures, and civilizations innovate to survive. Chaos replaces rhythm, unpredictability governs survival, and intelligence becomes a tool for navigating instability. Yet even in chaos there is beauty. The night sky is darker, revealing brighter stars, distant galaxies, and the vast expanse of the cosmos. Landscapes shift unpredictably, creating ever-changing patterns of mountains, rivers, forests, and deserts. Oceans pulse in irregular rhythms, offering glimpses of continuity amidst turbulence. Life thrives creatively and resiliently. Species innovate, ecosystems reorganize, and civilizations endure through foresight and adaptability. Every organism becomes a testament to the power of survival in a world unbound by lunar stability. The moon's absence does not erase life, it reshapes it. Earth endures, ecosystems adapt, civilizations innovate, and intelligence persists. In chaos, life finds opportunity. In unpredictability, resilience is born. The moon is more than a celestial companion. It is a stabilizer, a protector, and a silent architect of life. Without it, Earth continues, but under a new set of rules. Extremes govern, adaptation defines, and survival depends on creativity and foresight. Life endures not by stability, but through its capacity to respond to change. Civilizations, if they emerge, are mobile, adaptive, and resourceful. Species evolve in fragmented niches, testing the boundaries of survival and intelligence. The moon's absence magnifies the remarkable resilience of life and the delicate balance that sustains it. In the end, the moon reminds us of our planet's fragility and the interconnectedness of the cosmos. Its presence allows rhythm, stability, and predictability. Its absence demonstrates the remarkable adaptability of life. Whether illuminated by its glow or left in darkness, Earth is alive, resilient, and endlessly fascinating. The moon teaches us that life is a product of both stability and adaptation. It reminds us that survival is not guaranteed but earned through innovation, cooperation, and the relentless pursuit of balance in a universe of extremes.